Okay, calculus, we're going to jump right into this video because this is a big one. Function analysis, three-part series. We're going to start out simple and get more complex as we go. But just kind of remember, this is a big deal. Function analysis is huge. It's kind of an accumulation of all the things that we have been working on so far this semester. So let's jump right into it, just with the basic stuff. So in pre-cal and pre-calculus and maybe even in algebra 2, you looked at functions that had curves and stuff, and you mostly looked at how to find these zeros. And we're going to come back to this later because that does matter, and there's some information in there that's helpful to us in calculus as far as being more efficient with our analysis. But now we're not just looking at zeros, we're also looking at curvature. Is it going up? Is it going down? Is it bending in? Is it bending out? Is it flat? Is it vertical? All those kind of things. So let's start out with the basic, very basic. Okay, so right here, I'm going to draw a red line kind of going over this piece here. And that means that the function is decreasing. So when it's decreasing there, the slope is negative. Slope is negative. And then when the function is increasing, when it's going up like this here, we're going to call that increasing. And let's use purple for the in-between. It's kind of like a mix of the red and blue. And we would call this a constant slope. It's flat, where the slope equals 0. So that's kind of our three types of things that we're looking at. For constant slope equals 0, for the positive slope equals increasing, all those kind of things. So let's look at increasing curves in particular. So these are all increasing curves, and there's three different ways that we can have it. We can have it just perfectly straight like this. Whoops, didn't want to do that. We want a diagonal line. So we can have this perfectly straight line. Or we can still have, even though this is increasing and this is increasing here, we can have it bend in three different ways. But the thing that's true about all of these, the pieces that they all have in common, the slope of the tangent lines anywhere on here, slope positive, 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 positive. These are all positive slopes. These are all positive slopes. They're all positive. And let's look at kind of the opposite thing. We're looking at now decreasing. So we're going down from one high value to a low value. So here we're going down. We're going down. And even though we're going down kind of on average, we should also consider that the tangent lines, the slopes of all the tangent lines here, are negative. These are all negative. And how can we go deeper with that, kind of with the calculus and algebra that we've been working on? And here's the key point. Here's the thing that they all have in common. So in other words, if we're, let's jump back here for a second. If we're negative, that means that the derivative, f prime of x, is less than 0. It's negative. And if we're positive, if the slope is positive, that means that the derivative, f prime of x, is greater than 0. It's positive. So then here, this is kind of a summary of how we are talking about this. So if f prime of x is greater than 0 for all x in that interval, then it's increasing. And if f prime of x is less than 0 for all x in a, b, then f is decreasing. And if it equals 0, if it's equals 0 in that interval, then it's just constant. There is no slope. It's a flat, constant slope. This is huge. This is our vocabulary. This is our vocabulary that we're going to be using over and over and over again. This is how we are going to respond to free response questions in particular. But this is how you demonstrate your understanding. Oh, looks like we're getting full here. Let's see if I can go make some room. I'm going to pause this and then delete some files because we got too many video files on this computer. All right, there we go. We made some space on the hard drive. Now we're ready to get back to business. So let's go even further. All right, so this table that we were just looking at, this table is all about slopes, up, down, or flat. This first one's up, this second one's down, this third one's flat. But now those slopes can have bend in them. And the bend we describe kind of as concavity. So the concave up, right here, and this is concave down. You know, would it hold something in it or would it spill out? And I like to think of this as happy or sad. Is it happy or sad? What is the graph looking like? So what is true about the slopes of the lines as you go left to right? Okay, so here's where it gets a little bit different. You know, it's hard to do this with just one hand, but I like to show this with multiple things happening. But let's see if we can measure these things. I'm going to do just a tangent line here, and another tangent line there, then more and more and more and more. Here we go. We got a bunch of tangent lines. And then we're going to look at these tangent lines kind of in order. So if we look at this first one and this next one,